Alright, is everybody ready? There's two things I want to talk to you about this morning. First of all, I want to go through your first assignment, which I'm going to give out this morning. And second of all, I want to go through the solution to the lab on Tuesday. So the assignment thing is slightly more fun, so let's do that first. I'll show you what I want you to do, okay, and I'll explain how I'm going to grade it. And then I'll let you guys pick when you want to submit it. We'll decide as a class, you know. I'm thinking maybe 4 or 5 weeks, something like that. So, there's two versions of this assignment, right? There's the bare minimum that you have to do, and then yesterday I like to make programs about my dogs. So I started to kind of, what would you say, skin the assignment yesterday. So I'll show you the bare bones version, and then I'll show you the Tara up version, which is basically the assignment, which has been Tara'd up. Tara's one of my dogs. Okay, and yeah, so I'll show you the bare bones. No, maybe I won't even bother showing you the bare bones. I'll show you that afterwards. I'll show you the Tara'd up version first, it's kind of more fun. And then I'll explain how I'm going to grade it. Now, you kind of have enough processing to do this assignment already, but obviously there's more stuff that we'll do over the next few weeks, and I do want you to take the time. If there's something in particular you want to include in this assignment, you've got to go and learn it yourself as well. So I'm expecting people to do self-directed learning and take responsibility for doing whatever coolness you want. The way the assignment is going to be graded, for actually implementing what I'm going to show you, the bare minimum on the screen, which is what I'm asking you to do, you get 50% of the marks for the assignment. So the remaining 50% of the marks for the assignment is for whatever else you can come up with yourself. And I'll make a few suggestions for things that you can add to the assignment to make it basically more cool. So this is the Tara'd up version of it. I call this game Tara Squares. Let's open up Tara Squares. Recent. Are you all really excited? This is like a cool game. This is a game, by the way. So I expect to see you all playing each other's games at the labs and stuff. So now, let's see if there's any sound here, because actually I put some sound in it as well. Someone's got any MP3s. Cool. Can you hear that? Alright, so that means the sound in the room. Okay, so here's the game. Here's the Tara Squares game. So it launches like that, and you get a splash screen. So this is number one requirement. You have to have a splash screen with some text on it. And then you press the space key to begin, right? And so actually, I'll just tell you the idea of the game first of all. There are some squares coming from the top of the screen, 2 different types of squares, ones that you have to avoid and ones that you have to get in order to get points. So that's basically the gameplay in this game. So this is you down at the bottom, the blue square, and see these black ones? You've got to avoid those. I'll show you what happens if you hit one of those black squares. You get that sound. And if you get one of these ones, you get the growl of contentment versus the growl of anger. And you've got basically 3 lives, and your score increases. There you go. Your score increases, and that's it. And then you get game over. And then you press space to play again. So there we go. It speeds up. You know, it speeds up a little bit. As you're playing, it gets gradually faster and faster. You're a Tara. Such a good dog. Would anyone like to go? Yeah. Come on up and have a go. See if you can beat my high score of about 7. You've got 3 lives. Just back and forth, yeah.
Does the Tara square get faster? Blue?
Yes, that gets faster. Everything gets faster. You gotta avoid the black ones and get the red ones. The red ones are good, the black ones are bad. Don't do it. Okay. I'll put a YouTube video up of this assignment, just of the assignment itself, just as a play, so you can see what it does. So you get more or less 50 marks for just implementing that, okay? So the things coming down from the top, you don't have to put in the dog sounds, obviously. Put in your own sounds, put in your own sound effects and stuff. Yeah, that's pretty much it. That's your assignment. Okay. So lots of things you can add to the assignment. So some suggestions would be allow different types of power-ups and stuff, so that as you know, there's not just red ones and black ones. There's other coloured ones that maybe increase the speed, or that give the little blue square some temporary protection. You could also put in different levels, so that it starts out slow, and then you have to do like maybe 50 squares, and then it gets onto the second level, and you've got some more gameplay on the second level. Another thing you could put in would be the ability for the blue square to shoot the black squares. So all kinds of ideas like that, and I don't want you to limit yourself by the constraints of the assignment. Come up with whatever you like, and that's pretty much it. That's your assignment.
Something like that?
Yeah. So the core things that you have to have is a splash screen, a gameplay screen, and a game over screen. You have to have the ability to get points and the ability to have lives. You have to have things coming down that can collide with some sort of player at the bottom of the screen, and that's pretty much it. That's the core things in the assignment, and for implementing all of that, you get 50 marks. Now, in terms of how long it should take you to do that, it's really easy. Once you get kind of good at processing, once you get a bit better at it, it shouldn't take you too long. Like I went down yesterday and I peeled some potatoes, and I put the potatoes on to boil, and I went upstairs and I started coding that, and I had about 50% of it done by the time the potatoes were cooked. So it shouldn't take you like a massive amount of time. I mean, I'm thinking it's going to take you, if you know you're processing, it shouldn't take you more than a few hours or maybe a half a day to complete the core thing. But on top of that, then I want you to just go crazy and put whatever else you want in there. Yeah?
Did you boil the kettle before you put the potatoes on boil?
No, I'm including the boiling the kettle time, so like that's an extra 3 minutes. And then at that stage I had the character moving around at the bottom of the screen, I had arrays created for the things coming down at the top, and then another hour and I had more or less had it complete, so it shouldn't take you too long to do the core thing. I will say though, of course, if you can't program, then there's no amount of time that will enable you to create this. And I just also want to remind everybody about the contract that most of you signed at the start of the year, which obviously prohibits plagiarism. So if I find that somebody has copied somebody else's assignment or is getting code off the internet and submitting as part of your assignment, then you'll be in breach of your contract and you'll get 0 marks for the assignment, possibly a breach of academic regulations, and you might get expelled from DT. So I would strongly encourage people not to do that. Yeah?
Can we change the format of the game as long as
Sure.
they collide?
Whatever you want. Go crazy. Yeah, make it into whatever you want, right?
Maybe a different game altogether.
No.
It'd be like
It's not a different game altogether. No, because I'm going to give you the opportunity to do some, because there's certain things I want you to learn in implementing this game. So, like, first of all, the collision detection is obviously a joint if statement, or a number of if statements. Those things coming down the top, what do you think they are? How do I hold them in the game? They are an array, okay? So there's an array in there that I want you to get used to programming arrays, and then I want you to get used to just managing variables and, that sort of thing, and yeah, pretty much that's it, So there's some certain learning outcomes I think you'll achieve if you do this assignment from scratch yourself. And then in the second semester, you'll get the opportunity to make whatever you like for your assignment, right? So how long do you think you need? Give me a date. Who's your class rep? Do you want to have a think about it? Let me know on Monday.
Monday week.
Huh? Monday week. I'm thinking about 4 weeks' time. Something like that. So I'll pick a date now and we'll put it in, and there will be no deviation from this date for individuals. If anybody can't meet this date for any reason, if you have personal circumstances or whatever, of course things happen, I would say to people, don't leave it until the last minute, because if you leave it until the last minute, you're just going to get yourself into trouble, So better to start working really today, or over the weekend, or whenever you have some spare time to start thinking about what you want to make. And particularly the extra 50 marks, where you get those extra 50 marks in the assignment. There will be about 5 pieces of CA that we'll have to do on this module. So you'll probably have a second one before Christmas, something over Christmas. There'll be 1 or 2 lab tests, and then there'll be a big assignment in the second semester. So this is probably going to be worth about 10% of your overall mark, okay? Because there'll be 5 assignments, it's 50% CA. So,
7th of November then?
Huh?
7th of November. It's a month.
7th of November is 1 month, is it?
It's
Yeah.
4 weeks, like.
What's that? Cool. Does that suit everybody? Great. So 7th of November it is. If anybody, for some reason, anything happens and you can't be there, everybody needs to do a demo, by the way. Nobody gets a mark without a demo. I think I've sorted out the Google Classroom thing, so we'll try and get everybody to submit through that rather than through web courses, but I'll let you know well in advance. If for any reason that you can't meet the deadline, you need to fill out a thing called a PC1 form, which is a Personal Circumstances 1 form, and submit it to the exams office. You don't submit it to me. Otherwise, it's considered as a non-submission, okay? And I can't give anybody an individual extension unless you fill out that PC1 form and submit it to the exams office, just in the interest of fairness to everybody. Is that clear? Does anybody want to ask me any additional questions about the assignment? Are you all really excited? I must say I'm very excited to see what you guys come up with. I'm intrigued. So, any other questions about the assignment? Is it okay with everybody? You think it's okay? You all be able to do it? Yes. Good. Confidence.
Is there a minimum requirement?
What's that?
Sound files.
No sound. I'll show you what the minimum requirement is, right? That was just something that I hacked together in about an hour or so. This is the minimum requirement. Okay, so just the text, press any key to begin, and then this. This is kind of the minimum requirement, which is essentially just a game without any kind of skinning and no sound or anything. It's not nearly as much fun.
That one's running a bit different to your one. Your one had cells.
Yeah, that's right. I actually just changed that in the other one, so I think it's probably better if you do the cell thing.
Okay.
But that's pretty much the minimum requirement. That's the minimum requirement. Okay. All right, but everybody, everyone's real quiet today. Is it because you're all in shock, or I'm sure you're not? It's not that hard. You all know how to do it now, don't you? I mean, that's literally kind of about a lab's worth, or maybe 2 labs worth of work. Yeah. Cool. All right. Is everybody happy? Good. Good. Let's do the solution to the lab then. Okay. Okay, so here's the kind of core thing that you guys were given on Tuesday, the little, if you like, the skeleton code. And what we want to do is we'll try and fill in the gaps here. Okay, so I've kind of put what I think needs to go into each of the different sections into the kind of skeleton code that I gave here, right? So how many people completed it? Just out of curiosity, how many people weren't able to complete it? How many people took the time after the lab to complete it? Stuff. Remember, you all agreed to do that at the start. Anyway, this is what we need to do, okay? So, the way I would think about this, I basically have a 16-element array, and each element in that 16-element array is a Boolean. And I need to draw a square on the screen for every element of that 16-element array. So I've changed this around very slightly, just because I think it's slightly easier if you make that thing fit the full size of the screen. Can I just borrow a page or something? Can I just borrow a page just to clean the board? Thank you. Okay, so basically have the screen, which is this width and that height. And what I want to do is draw my 16 squares in here so that they fill the width of the screen. So the first thing I think we need to do is we need to calculate how wide is one square going to be. And that's obviously a very simple calculation. You just take the width of the whole screen and you divide by the number of cells that you want going across the screen. And I call that the gap. because that's basically the, well, let's call it the cell width, right? So let's declare a variable for that, int cell width. We set that in there. And then down here, let's calculate the cell width first of all. So that's going to be equals to the width of the screen divided by, how do I know how many elements are in the array? Couldn't use that, yeah. That's the C way of doing it. In processing or Java, how would I know how many elements are in an array?
You declare the array and then just do dot length.
Dot length, exactly. So there's the array declared up there. That's the bytes array. So I can take the bytes array and divide by bytes dot length. And then that's going to tell me how wide each cell is, okay? Next thing I want to do is, in here, let's do some stuff here. What I want to do here is I want to iterate through that Boolean array, and I want to fill in the cells, okay? So, to iterate an array, I've got to start at the 0th element and go up as far as the number of elements in the array. So that's going to be a for loop, for int I equals 0, semicolon, I is less than the number of elements in the array, which is going to be bytes.length again, semicolon, I plus plus. Now I need to calculate the actual position where I'm going to draw the square. And so in other words, it's the top left-hand corner of that square. So let's declare two variables. Well, let's make them ints, doesn't really matter. Int x comma y. And y is going to be how far down the screen I want to draw. We'll just pick a number for that. Let's pick y equals 300. And then for x, what I need to do is actually do the calculation to calculate the x coordinate. And that's going to be equals to the cell that I'm talking about, which is going to be I, multiplied by the width of each cell. So if I is 0, what's x going to be? X is going to be 0. And then if I is 1, x is going to be cell width. If I is 2, x is going to be twice the cell width. So that's how I calculate the x coordinate where I need to draw that cell. And then I'm going to use the if statement, and I'm going to check to see if the bytes at position I is turned on. And if it's turned on, then I'm going to do a fill of black. And if it's turned off, I'll do a fill of white. And then I'll draw my rectangle. So my rectangle is going to start at the position x and y. So x and y being the top left-hand corner of the rectangle. And then the width and height of it, let's make it equals to the cell width. Okay, so we'll check that and see does that work before we move on.
Do you have a cell height variable?
Sorry, cell width I should have called it, yeah. Cell width. Come on. Let's run that. And now I get the cells drawn across. Is that okay? Does everybody understand how I did that bit? Yeah, are you sure? Okay, cool. So the next thing I said was let's test to make sure that the Boolean on and off thing works. Let's set some of the cells on and make sure that they get turned on with black. So if I maybe pick, you call them bytes. Did I call that bytes? I should have really called it bits, shouldn't I? So let's just set the cell number 2 is equals to true, just to make sure that the correct ones get turned on. So there we go. So that one gets filled in black, and then everything gets filled in white. Is that okay with everybody?
Yep.
Cool. So the next thing I suggested that you did was to go and do the calculation. And we did the calculation in the class last week, but we've got to change this binary to decimal function so that it works with a Boolean array rather than a string. Okay? So what I need to do is take each one of the bits, and if it's turned on, I'm going to add some power of 2 to some number that I'm going to return. So, yeah, this is the way I did it. The other kind of slightly weird thing about this is that I need to do them in reverse order. So if I'm talking about bit number 2, that's actually, you know, if I draw it like this, there's my Boolean array with array element number 0, 1, 2, 3, 4. But the power of 2 value that I need to get is going to be the sort of opposite of that, isn't it? So this is going to be bit number 15, this is bit 14, bit 13, bit 12, and so on down as far as bit number 0. And so they're the powers of 2 that I need to use. So 2 to the power of 0, 2 to the power of 1. So I need some way to take these numbers and get these numbers out of it. And there's loads of ways to do that, but this is the way I did it. I declared a variable called int bit, and I said bit was equals to bytes dot length minus 1. So bit starts out as being equals to the value 15. If I've got 16 bytes, 16 elements in that array, then bit is going to start out being 15. So then I go for int I equals 0, semicolon, I is less than bytes dot length, semicolon, I plus plus. And then I can say if bytes at position I is true, the return value plus equals 2, and how is how you do power. So it's the power of 2 to the power of the bit that I'm talking about. And then I need to go bit plus plus there. So, and finally I return ret. So there's loads of ways you could have done that. That's the way I decided to do it. Does everybody understand how that works? So I start bit at 15, and then I subtract 1 from it, so then it's 14, 13, 12, 11, so on. And then I get the power of 2, and then that's how that one works.
You have bit adding there. You don't want to subtract.
What's that?
Then you said you're subtracting.
Oh, you're right. I need to subtract. Quite right. Good man. Well spotted. Did the rest of you spot that error? I think we should do star jumps or something on a Friday morning. Everyone's really quiet today. I don't like that. I prefer when people are more chatty.
Could you do it that you just minus by I at the end of the power instead of I minusing by bit? So the bit never changes, but you're minusing by the I that's incrementing
You could
itself?
take bit minus I, of course.
And just remove bit minus minus.
You could indeed, definitely. That would work just as well.
Yeah.
Perfect. That's another very good solution. So that's how binary to decimal works. And so, you know, just to test that this works, let me see. Let me just test to make sure that works. I'll put some code in here into the setup. In fact, you know what? It'll already do it. Because if I just set a couple of the bits to be true here, let's set bytes at position 2. Let's say bytes at position 15. Well, let's say 14. If I do bytes at position 14 equals true, what value should get printed out? What's the binary number? What's the decimal number that's going to get printed out? Have a think about it.
2.
2, exactly, because it's going to be bit number 1 is going to be bit 15, and bit number 2 is going to be bit 14. Cool, let's try that and see does that work. So there we go, I got 2 printed out on that. So then the last bit of this lab is just to toggle those bits on or off, depending on where I hit on the screen. So again, there's several ways to do this, but I think this is probably the most efficient way. What I need to figure out is when the mouse X is pressed, which bit does it correspond to? So the simplest thing to do is just to take is going to be equals to the mouse X divided by the cell width. And that's going to tell me which bit I've clicked. Alright, let's think about how that might work. So this is bit 0, this is bit 1, bit 2, bit 3, bit 4. Let's imagine for the sake of this little discussion that each one of these is going to be 50. Okay? It probably isn't because it's going to be something divided by 16, so it's not going to be 50. But if we imagine that this is 50 here, and if I have the number 75, which means I've clicked like halfway in between there, if I take 75 divided by 50, I get what? You get 1. And you get 25 remainder. So now I know I'm in cell number 1. If I was to take 225 and divide that by 50, what do I get?
4.
I get 4. So I get 0, 1, 2, 3, 4. And that is the correct cell, you know, because 200 is going to be where this one starts, and the way you do it. Does everybody see that? How many people did that a different way? What did you do? Oh, come on. I was walking around the lab and I saw lots of different solutions to this. I'm sure you did lots of different solutions. How many people wrote a for loop? Alright, that was the way I did it first. And then I saw somebody in the lab, actually it was you, who solved it this way, and I thought, yeah, that's much more clever. Of course, you don't need to do a for loop, okay? All you need to do is take the x-coordinate, divide it by the cell width, and that will tell you what cell you're in.
You want the Y as well, don't you?
Yes, we do need to check the y as well, yeah. So we'll check to make sure the y is greater than 300. So that's that thing. And then, you know, better to do something like this. Make sure that I'm in range of it. If the y is greater than 300, and the y is less than 300 plus, and this 300, this is bad. I should have probably declared a variable for that. Plus the cell width. Then I go and calculate the x bit, and then I can go bytes at position bit is equals to not bytes at position bit. So that will toggle it on if it's off and toggle it off if it's on.
Where you get bit from?
Bit is there, I've calculated. Hopefully that's, yeah. And then that's just going to turn it on if it's off and turn it off if it's on. So that's, does everybody understand what this does here? If the value is true, it will set it to be false. If the value is false, it will set it to be true. So can you understand that that's saying this is just an assignment, and then this not is going to be, if it's true, it will make it false. If it's false, it will make it true. Is that okay? So let's run that and see what happens. Y, so of course that should be mouse Y. Like that kind of looks okay. So if I click here and here it doesn't work, and hopefully if I click in here, hooray, it works. Awesome. So that's the solution. Anyone want to ask me any questions about it? Alright, Erin's real quiet this morning, so... Yes!
Not so much a question about the solution, but more about defining variables. If you define a variable in the global area,
Yes.
will that variable be, we can not change that at all? Will it just stay as a set variable?
No, you can change it. Yeah, it's just a variable. You mean if you declare a variable up here?
Yeah, I was wondering if it was just a privately declared variable, then you can only see the value of it, you can never actually alter it.
Well, no, because look, if you see here, like center x and center y, here I am altering them here in the setup method.
Yeah, but they're not equated to anything right now, they're just declared. Here's
Yeah, they're just
them,
declared.
and
Oh yeah,
equate
sure. No, you can. If you declare it and assign a value to it there, I mean, you could assign these to be 0 up here, and then you can change their values. Yeah, good question. All that happens is that's just their initial value, and then it changes the value. Okay, is that okay with everybody?
Trying to choose complement.
2's complement. I didn't do it, but how would we do 2's complement? We can try it. How does 2's complement work? Well, you guys tell me how 2's complement works. Let's see, because it's been a while since I did 2's complement. Let's see if we can work it out. Oh, could be tricky, huh? Actually, it's probably not too tricky. I'm trying to think, is there a trick way to do it? Like, let's see how 2's complement works. If I take this number here, so that number in decimal is going to be 1, isn't it? If I want that to be minus 1, what would I do? What's that? First 0 becomes a 1. Yeah, so what would I do? What's the mechanism for converting that to minus 1?
Flip one and one.
Yeah, so we flip all the bits and we add 1 to it. So if I flip the bits, that becomes 1, 1, 1, 1, 1, 1, 1, 0. And then I add 1 to it. So it becomes this one. 1, 2, 3, 4, 5, 6, 7, 8. So that's the number in binary. That's the process for doing 2's complement. So if I want to figure out what's the decimal version of that, what do I do? Hello? Guys, I'll go home if you're not going to wake up a bit. This is pointless, right? Would you please try and wake up a little bit and answer some questions here? Like, I know this already. I know all this stuff, right? You guys need to know this stuff, not me. I already have a PhD and a degree and a job. You guys don't have any of those things. So here's the sequence of binary numbers. How would I convert that to, how would I figure out what does that actually represent?
Yes, you go to 2 to the power 0, 2 to the power 1, 2 to the
Sure
power
thing.
2, 2 to the power 3, then you add all together, then you have answer.
Totally. But this being a negative number, can I just do the process in reverse, flip the bits and add 1, and I'll get back? I think that's what you do as far as I remember. Let's try that again. If I flip all the bits in this, I end up with 1, 2, 3, 4, 5, 6, 7, 8, and I add 1 to it, and I end up with that number there. So that's what I end up with that number. So, yeah, given that sequence of binary digits, how would I know if it's, how would I know? I just have to do the same thing, flip the bits and add 1. That's only if it's a negative number though. What if it is actually this sequence of numbers? You know? 5, 6, 7, 8. I'll tell you what, here's a great plan. I'm going to put the code up for that one right now. You guys can type it into your computer, figure it out for yourselves. We've got half an hour left. I'm not going to tell you, because I don't even know. So there's the code. Those of you with laptops, right? You can type it in, or you can use your program from Tuesday's class. Try and figure out how to do the 2's complement bit. So that if it's a negative number, you're able to print out a negative number. If it's a positive number, you can print it out as a positive number. I don't know. You guys figure it out. And then tell